Hello, my name is Ted Grantham. I'm with the University of California's Agricultural and Natural Resources Division. I'm a cooperative extension specialist in climate and water and a faculty member on the Department of Environmental Science, Policy and Management at UC Berkeley. Go Bears! Today I'm going to give a talk on drought, climate change, and California water management. As you've seen from this speaker series, drought has had an effect on really all aspects of our natural environment and agricultural resources, and you've seen talks affecting how drought has affected crops and groundwater and wildlife and other issues. Today I'll be focusing on this relationship between drought and climate change and really build upon the previous talk by Dr. Tapan Patek on the effects of climate change on agriculture. I'm focusing today specifically on the effects of climate change and drought on California's water management system. I'm going to start with a brief update on California's drought here in 2016, describe some of the science that we have on describing our current drought and climate trends related to drought, talk about implications for California's water management system and the Delta in particular, San Francisco Bay Delta, and then talk a little bit about adaptation strategies and how we might cope with similar droughts and climate stressors into the future. The main messages that I want you to take home today is that the current drought offers a glimpse into our future in California. And we can expect that as the drought has really affected much of our system, that climate change will really stress all aspects of our water management system, particularly in the Bay Delta, which I'll describe today. However, multiple strategies do exist to minimize the effects of climate change and drought, and I'll give some examples of that at the end of my presentation. So where are we now? As of July 2016, when we look at our precipitation for the year, in Northern California at least, we are actually above average. So it's been a relatively good rainfall year for Northern California. However, much of the state has actually received less than average rainfall in this winter and is still in a condition of extreme drought. So important to keep in mind the drought is not over. So what is different about the current drought compared to previous droughts? Droughts are a natural occurring feature in California. We've had a lot of droughts in the past, and we can expect to have more in the future. So what is unique, and is this drought really unique? This is a slide from a recent paper by Noah Diffenbaugh over at Stanford that explored drought patterns in the state of California. What you see here is a Palmer Drought Index, which was essentially a measurement of drought severity that takes together information on precipitation and temperatures to give you a measure of moisture in the environment. What we see here is that when that Palmer Drought Index falls below -1, we consider that to be a drought in the state. So all those dots that you see in the lower portion of this graph represent droughts that we've had in history. And so what you see is that from the start of this period of record, which is 1896, we've had about 14 severe droughts since 1896 to 1994, and we've had 6 droughts since about 1995. When we look at the percentage of the time that we experience droughts, we've actually seen in that earlier period of record, we only had droughts about 14% of the time, whereas in this past 20 years, we've had droughts in about 30% of the time. So there seems to be an increase in the frequency of drought in California. So what's going on here? When we look at historic precipitation and temperature patterns, again here, these dots represent our drought years. We see that precipitation patterns have been highly variable over the past century or so, but there's no apparent trend in our statewide precipitation. However, when we look at our temperature graph here on the right, we see a significant increase in statewide temperatures associated with climate change. And what we see is that during years of droughts, we tend to have these much higher temperatures. And so in the future, what it seems to be saying is that we can expect to see a higher frequency of drought because of this general increase in temperatures statewide. When we look at another paper, this by Yoon et al., Nature Climate Communications, we see that additional evidence of future increases in not only drought but also flooding. So this general pattern of increase in climate extremes are predicted by our current climate models. And the numbers suggests that we expect to see an increase of about 50% in the number of severe drought and flood events in the state by the end of this century. So what does this mean for California water? Some of the direct impacts of these trends are associated with less snow and earlier snowmelt, prolonged lower flows in our rivers and streams, higher water temperatures, and sea level rise. I'm going to talk a little bit about what this actually means for our water supply system, but before I get into that, I want to provide a little bit of context of California's climate. We have strong variability in our precipitation patterns. We have strong seasonal precipitation. This graph here in the upper left shows our precipitation patterns for the San Francisco Bay Area. And what we see, and this is fairly true for most of the state, that we receive about 90% of our rainfall or precipitation between November and March or April, followed by a prolonged dry season. We also have extraordinary interannual variability. And this lower panel shows the interannual variability in rainfall across the United States. And we can see that California really is an outlier. Those darker colors of greens and blues represent much higher variability in interannual rainfall, so much greater frequency of wet and dry years compared to much more stable conditions in the eastern United States. Not only do we have strong temporal variability in the way that our rain falls within years and across years, we also have strong spatial variability in where rainfall falls in the state. What we see here are rainfall or runoff patterns, rather. This is the water that's actually coming off the landscape that can be used to fill our reservoirs and flow in our rivers. Most of the runoff that's generated in the state comes from the areas that you see in blue. Those darker and lighter blues represent about 40% of California's land area, but generate about 80% of our total runoff. In contrast, the colors that you see in the light and darker oranges also represent about 40% of the landscape, but they only generate about 1% of our state annual runoff. So there's a really large difference in where and how much runoff is generated across the state. And you'll notice here that one area that shows up in dark orange is the Southern Central Valley, which is one of our most important agricultural producing regions in the state that naturally produces very little rainfall locally, which leads us to our water storage and distribution system in the state of California. In order to cope with this extreme variation, both seasonally, interannually, as well as spatially, we've built a massive system of water storage and conveyance infrastructure to move water really across the state. What you see here are in the boxes are various large dams. They're roughly sized by capacity. The colors represent the principal owner or manager of the dam. So the reds are federal projects, the blues are state projects, and the greens and yellows are either privately operated or other state and federal projects. And the lines are also our aqueducts and canals. And so through this water storage and distribution system, we're basically able to move a drop of water that falls in the Trinity Alps in Northern California down to the tap of a resident in San Diego. Really extraordinary system of water storage and distribution. So what do these trends in climate and hydrology mean for this water storage and distribution system? Well, first, one of the most pronounced effects of climate change and drought is on our snowmelt in the Sierra Nevada mountains, which is the major mountain system running on the eastern side of the state. These graphs show trends and projections into the future of various climate parameters. What you see first is that we don't really expect to see a significant change in precipitation. The colored lines on each of these plots represent different climate models, and the black kind of squiggly line represents the multi-model average. And so when we look at cold season precipitation, or that basically water that's falling as rain or snow for this period of record, we don't see a significant trend starting from 1960 and looking into the future. However, when we look to the right of cold season temperatures, we see a significant increase in in those temperatures consistent with statewide patterns. So what does this mean for snow and snowmelt? Well, first of all, warmer cold season temperatures mean that less precipitation will be falling as snow. And so that panel on your lower left shows the decrease in the percentage of precipitation that's falling as snow in these mountain regions. It also means a general shortening of the snow season. And so the last day of the snow season is going to expect it to become earlier and earlier. So sorry about that, skiers. So less snow means less water supply for the state. And this is just another way of looking at these trends of decreasing snowpack. What you see on the left is our historical average snowpack relative to average April 1st conditions. That shows sort of the distribution and the amount of snow that's typically present in the mountains. When we look forward and project what we expect the climate to be into the future, on the right you see two different climate scenarios, one with moderate warming and one with more severe warming. We can expect to see somewhere between a 20 to 40% decrease in the amount of water available as snowpack, which supplies our system. These changes in snow runoff and water availability have implications for the entire water management system, but I'm going to focus specifically on the San Francisco Bay Delta, which is generally considered California's water management hub. The Bay Delta occurs at the confluence of the Sacramento and San Joaquin rivers, the two largest rivers in the state of California, and they meet and flow into the San Francisco Bay, which of course is the salt water from the ocean mixes with this fresh water to create seasonally variable saline conditions. The reason the delta is so important from a water management perspective is that we have two or several major diversion pumps in the southern part of the delta that take fresh water from the Sacramento and San Joaquin rivers and deliver that to the south for agricultural and municipal water needs. These water exports are really critical to water users in Southern California. They deliver over, on average, 9 million acre-feet of water from these water management projects, which support nearly 4 million acres of irrigated agriculture and contribute to the drinking water supplies for about 25 million people in Southern California. Of course, the Delta also is an ecosystem and supports an extraordinary diversity of fish and wildlife that have been severely affected over the past century of land use and water use in the Delta region. And what we've actually seen is the collapse of several estuarine and migratory fish species in this region, including the Delta smelt, the longfin smelt, striped bass, and winter-run Chinook that pass through the Delta on their migration to their spawning areas in rivers in Northern California. Now, there are several factors that have contributed to the decline of these freshwater fishes, but one important contributing factor appears to be the relationship of and the dependence of these freshwater fishes on delta outflows. And these are data that show basically that the abundance of longfin smelt are highly correlated with the amount of outflow from the delta. This graph shows us the patterns and volume of water coming out of the delta from about the 1930s to the present time. It also shows the amount of water that's being diverted or withdrawn upstream of the delta and the amount of water that's been exported from those major projects that I discussed earlier. So what you see is there's been a high variation in the amount of outflows. A general increasing volume of water has been withdrawn upstream of the delta, and starting about the 1960s we've seen a slight growth in the volume of water exported from the delta by those major projects. What's important to note here is that when that purple line falls below those bars, it basically means that more than half of the water that naturally would flow to the delta is either being used upstream or being exported. In the past 40 years, there have been about 15 above normal and wet years in terms of precipitation, but the ecosystem itself has experienced only 7. And there's actually only been one naturally occurring critically dry year in the past 40 years, but the ecosystem has experienced 19 because of these upstream and water uses and exports. What this means essentially is that the delta has experienced, as an ecosystem, experienced a prolonged artificial drought. So again, looking at California's water management hub and how this system works. In order to get fresh water from these rivers into the pumps to export to the south, a sufficient level of outflow must be maintained to prevent the salt water from the bay from coming into the delta. In other words, we must maintain a barrier of flow coming out of the delta in order to prevent the water that we want to send south from being contaminated by salts. So this is a really important constraint that this management system has to deal with. Of course, as I mentioned earlier, there are also these fish species in the delta that have been experiencing severe population declines that also require and benefit from outflows to the delta. However, one of the misconceptions that I want to address today is this idea that these fish species are the primary constraint on exports to Southern California. This is an issue that has been very politicized in our state, and I'd like to take a moment to look at some of the data that show how much of the water is actually being constrained by environmental versus other constraints in the delta ecosystem. So when we actually look at the data from the last 3 or 4 years and look on a day-by-day basis what seems to be constraining exports from the delta, what we see is that for about 75% of the time, the constraints on delta exports are actually related to the need to maintain the salinity barrier at the delta, where the delta flows into the bay. Less than 20% of the time are delta exports actually restricted by regulations to protect fish species such as salmon and delta smelt. Given that salinity is such an important constraint in this system, it's particularly disturbing to look at projected sea level rise. Here we show what the delta will look like with an estimated 3 feet of sea level rise for the region, which is pretty conservative for what we might expect to see by the end of the century. And clearly, most of the delta would be at least partially inundated by these rising sea levels, which will make it likely difficult, if not impossible, to continue managing that salinity barrier where it currently is today. This suggests that our ability to export water from the delta is going to be severely, even further restricted under future climate change scenarios. And this is likely to affect agriculture that's already suffering from other stressors. So here's a map developed by the California Energy Commission that shows the agricultural regions with the greatest vulnerability, many of which occur south of the delta. So given that water supplies are likely to become even more limiting than they are today, we really need to focus on these vulnerable areas and take steps to build the resilience of these communities. So in summary, the frequency of drought appears to be increasing in California. Less snow and earlier runoff means less water supplies for people and the environment. The collapse of several native and estuarine and migratory species will likely lead to tighter restrictions on delta water management operations, but really salinity and other water quality requirements are currently the greatest constraint on delta exports and are likely to become more so. So that all said, we've actually seen some really promising movement to adapt California's water management system to new and changing conditions. So even before the drought, we started to see the decline in both urban and agricultural water use, despite significant increases in ag productivity and population growth. So this is very promising. And there is certainly room for improvement, but we should not forget the progress that we've made in improving water use efficiency, managing flood and drought risk, and protecting the environment. Of course, meeting our varied demands for water use in California will continue to be a challenge, particularly under a more warmer and variable climate future. And difficult decisions and trade-offs will continue to need to be made. But there are several promising strategies that exist and that are being explored right now that we should be aware of. The first, we've made really significant progress in managing our groundwater resources, and the importance of groundwater in our water management portfolio cannot be overstated. If managed sustainably, the ability to access and use groundwater, particularly in times of drought, gives us tremendous flexibility to minimize impacts and sustain productivity, particularly in the ag sector. And in general, the water supply benefits of sustainable groundwater management far exceed those that could be achieved through raising or expanding our surface water system. It's too early to know the outcome of the 2014 Sustainable Groundwater Management Act, but it's certainly a step in the right direction. One of the lessons we've learned from our current drought is that we were largely unprepared to deal with its impacts for the environment. Many environmental protections were rolled back, and several ad hoc measures were put into place to save endangered species. The state would greatly benefit from a more strategic and deliberate approach to ecosystem management. While trade-offs among the multiple management objectives will continue to be necessary, there's also tremendous potential for managing our environment for multiple benefits and to really improve the resilience of both ecosystems and society. And often the restoration and careful management of ecosystems can provide direct benefits to people, including recreation, water quality benefits, flood protection, in some cases even water supply benefits. And such win-win approaches are really being put into practice now. We're seeing, for example, the intentional flooding of agricultural fields on a temporary basis to provide habitat for migratory birds and fish, as well as to provide recharge benefits to groundwater. Levees are being set back to restore the natural functions of floodplains and reduce flood risk downstream. We're seeing improvements in water use efficiency that are freeing up new supplies that can be dedicated to the environment to sustain endangered species and maintain our recreational and fisheries uses. And overall, we're seeing a breakdown of our water management silos among water supply management, flood control management, and environmental management to explore these multi-benefit approaches that are really critical, I think, to creating a more resilient water management system overall. I've shown that our current drought really offers a glimpse into California's water management future, and the steps we take today to deal with this drought will really benefit us as we deal with a warmer and more variable hydrology. Climate change can stress all aspects of our water management system, particularly the San Francisco Bay Delta, as I described today. However, multiple strategies exist to really reduce these impacts that we can expect to see and overall maintain our water supply reliability and conditions of the environment. This is my contact information. Please feel free to email me with any questions or comments, and thank you for your attention.